All right, this is this video is going to be talking about scale factor, how that affects perimeter and area, and then once we know our scale factor, then what do we do with that? Okay, so this is the scale factor video. So we notice right away that our little triangle and this big one that we see here that's got all the lines through it, they look similar. Okay, do they share the same angles? Well, let's check. Yes. Yes. And yes, all three of those angles were the same. Do they have the same shape? I would think that they do. I think they have the same shape. Now, the question is do they have a scale factor? Well, let's talk about what that would even mean. How many times bigger does the larger triangle look? You might say 9, you might say 3. I'm going to just run this along this side. We've got this side, I'm going to do the bottom side here. 1, 2, 3. Okay, so far I'm thinking that side is 3 times bigger than the original bottom. 1, 2, 3, and 1, 2, 3. Okay, so the number that keeps coming up is 3. It looks like this triangle might be 3 times bigger. So my scale factor, I'm going to guess, is 3. I'm just going to throw that out there. Let's say scale factor equals 3. Now, what does that do to my perimeter? Well, let's find out. If this short side on the small triangle is 1, then that means that this is a 1, this is a 1, and this is a 1. This side here is also 1, 1, 1, 1. And in green, the hypotenuse, the angled side, is 1.5, so this is a 1.5, 1.5, and also another 1.5. So the original perimeter of my little triangle is 1, 2, 3.5. 3.5 units, whatever that is. Okay? Well, let's find out what this one is. We've got 1, 2, 3, 4, 5, 6, 7.5, 9, 10.5. Is that 3 times bigger than the 3.5? Multiply that out. Yes, it is. It is 3 times bigger. So I'm going to say that our scale factor is 3 because this little triangle here is 3 times smaller than this big guy, or the big guy is 3 times bigger. So my scale factor from here to here is 3. Well, what if I started with the big one and said that this was my original and the little one was the new figure? What would I do? Well, you could say that this little guy is 1/3 the size of the big guy. It's 1/3. Something interesting happens here. Scale factor is 3 from small to big, from big to small. Scale factor is 1/3. 3 is the same thing as 3 over 1. If you make the reciprocal of 3 over 1, you get 1 over 3. So the opposite scale factors are just a reciprocal. All right, well, let's test our theory and find out what happens to other perimeters. Let's go on to this next slide here. All right, so I've got this red parallelogram here, and is it similar to this other larger parallelogram? And what's the scale factor? Well, it looks to me like this guy is going to be 2 times bigger. Yeah, it's 2 times bigger. So the smaller parallelogram multiplied times 2 gives me my new larger parallelogram, which is 2 times bigger. I say, well, why isn't it 4 times bigger? Well, let's go back. 3 times bigger affects the perimeter. So we have perimeter right here. And my perimeter was 3 times bigger. So times 3. But there's another thing that's affected, and that's the area. What happened to my area? My area got how many times bigger? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. My perimeter is 9 times bigger. I just said area. My area is 9 times bigger. I wonder why that is. Scale factor was 3. Perimeter is 3 times bigger. Side lengths are 3 times bigger because this is now, the total thing here is going to be 3. So that's 3 times bigger. But the area is 9 times bigger. Well, there's a little song, scale factor song, and in the scale factor song it says, to make things bigger, it's more than 1. So we made our small rectangle here, we made this guy bigger. So our scale factor was more than 1. In fact, it was 3. To make things smaller, it's less than 1. So to make things bigger, it's more than 1. To make things smaller, it's less than 1. 1/3, we went from the big one to the little one. 1/3 is less than 1. To find the area, square it, it's fun. So that must mean that our scale factor of 3, if we square it, 3 squared does equal 9. Our new area is 9 times bigger. Okay, so to make things bigger, it's more than 1. To make things smaller, it's less than 1. To find the area, square it, it's fun. Scale factor, scale factor. What a beautiful song. Okay, so let's look here. Let's square our scale factor here. Our scale factor is 2. 2 squared equals 2 times 2, 4. Is our new area 4 times bigger? Let's find out. 1, 2, 3, 4. Yes, it is. Let's move on to another one. Let's try it again. Okay, we've got the nice triangles here. Are they similar? Yeah, they kind of look like it. Can we make a larger version of this small guy right here? Let's try. Let's put this one together. Put this guy together. Like so. And then we might have to do some manipulation. But we got it. And it looks like he fits perfectly inside there. How many times bigger would you say this larger triangle is? 2 times? I agree. 1, 2, or 1, 2, and coming up the left side, 1, 2. How much bigger is the area? 2 squared? 1, 2, 3, 4. 4 times bigger. Okay, now we got the rectangles. Does this look similar? Yeah, it does. Let's check to see if we got a scale factor. Looks like it's going to be 1, 2, 3 times bigger. Let's check it the other way. 1, 2, 3. Yes. Scale factor must be 3. So the area, if we square the scale factor of 3, 3 squared equals 9. Is our new area 9 times bigger? Count it out. Yes, it is. Now if we went from the small one. This guy is 1/3 the size of the large one. Does it take 3 of these to fill it? Yeah, it does. So he is 1/3 the size. So follow the arrows, the directional arrows. All right, again, another figure. Is this a reptile? Yeah. Scale factor is 2, area is 4 times greater. 4, scale factor is half, and their area is a 4th. Let's talk about that for a sec. My scale factor is half from here to here. What is half squared? Well, it's half times a half for 1. 1 times 1 equals 1. 2 times 2 equals 4. Is this area a 4th the size of this area? Yeah, it is. It takes 4 of them to fill it. Okay. The reason why this works, if this is going to confuse you, just ignore it. But I just want to prove to you why this squaring the scale factor thing works. The area, when I have my original, my 1, scale factor is 1, the area is 1. Okay? Now I'm going to move to a scale factor of 2, and that adds how many blocks? It adds 3 blocks. So it adds 3, and it gives me a total of 4. So far, if I square 2, 2 squared equals 4. All right, let's move into the scale factor of 3. So there I'm adding 1, 2, 3, 4, 5. I'll be adding 5 blocks, so scale factor of 3 plus 5 blocks. Let's try it. Erase these 2 guys here, or 3 guys here. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 there total. 3 squared equals 9. Let's move on into the next one. Let me do this real quick. Just move it down a little bit and over. Okay, scale factor of 4. Well, I'm adding 1, 2, 3, 4, 5, 6, 7 blocks to it, so I should be adding 7. Let's come over here and do some funky math. So we're coming over to a scale factor of 4, from 3 to 4. We're adding 7. We counted up. 5 plus 9 plus 7 equals 16. There it is, 4 squared equals 16. 4 times 4. Okay, beautiful thing. So there's the proof. If that doesn't make any sense to you, don't worry. It's okay. So triangles. We kind of looked at some triangles. Do they do the same thing? Yes, they do. We got some triangles that are isosceles here, just like this one. Rotate this guy right here in the middle. This one here. Flip it upside down. We got a nice reptile. Scale factor is 2. Area is 4. Here's another example of an equilateral. Scale factor 3. Area is 9 times bigger. And lastly, the right triangle. Same situation. Scale factor is 2. 1, 2, or 1, 2, 1, 2. Scale factor is 2 squared. 2 squared does equal 4. And lastly, the scalene, which is what most of us have trouble with, trying to visualize the reptile, but it does reptile. Okay, and the same rule would apply that we just looked at. Add 3, add 5, add 7. Same thing as what we just talked about. So, where does that lead us, or leave us? That leaves us with, what do we do next? How do we use this? Great, we know what scale factor is, but what do you do with it? You've got to do something with it. So let's put it to use. How many times bigger does the big triangle look than the small one? 2, 2.5, maybe 3 times. Okay, well, we've attached some value to it. The 2 is in the 6's. These are the corresponding sides. So now we can find the scale factor. So 2 times something gives me 6. Well, I recognize right away that that's 3. So 2 times 3 gives me 6. So if this side here is 3 times bigger, then this side also has to be 3 times bigger. So 5 times 3, x must be, 5 times 3, x must be 15. Okay, easy enough. Now there's this other cool thing called ratio. And ratio is the sides together. So not scale factor, but a ratio. So let's start over here. So instead of going from triangle corresponding side to other corresponding side, we're going to stay within the sides of the same triangle. So the 2 to the 5. So I'm just going to set it up like this, just like division, like 2 divided by 5. I could do it as 5 divided by 2. I just chose to do 2 divided by 5. And that has to equal, because we're saying it's corresponding, that has to equal 6 over x. Okay, so short side on top, big side on bottom. Short side on top, big side on bottom. Okay, so you could do scale factor here, 2 to the 6. But I don't want to do scale factor. I want to try ratio out. Let's see if we get the same answer. So what is 2 divided by 5? Punch in your calculators, that equals 0.4. So this side also must equal 0.4. So 6 divided by something gives me 0.4. Well, it's got to be a bigger number down there. If you could play around, eventually you would do 6 divided by 0.4. Replace the x, and that's going to equal 15. So no matter how you do it, 6 and 15, 2 and 5, whether you use scale factor or ratio, you get there. And what I encourage you is if you really understand ratio, then solve it with ratio. If you really understand the scale factor way, then do scale factor. If you don't get both of them, that's okay, as long as you get one really well. All right, that leaves us up to a shadow problem. Shadow problems and mirror problems are very similar. Okay, so we got this dude down here, and he's flying his kite. He's 5 feet tall, and he recognizes that his shadow is 4 feet tall. He's flying his kite, and the kite's shadow is 15 feet long. He measured it out. How high is the kite? Okay, so in this situation, we basically have 2 different triangles. We've got the 5 by 4, 5 foot by 4 foot. And we've got the bigger dude, 15. Oh, I'm sorry, 15 is on the wrong side there. 15's on the base here. 15 feet by, we don't know. That's what we're trying to find out. So 5 feet by 4 feet, x by 15 feet. Same situation as what we just did. We could do ratio, we could do scale factor. Okay. Right away, I don't necessarily recognize a scale factor from 4 to 15, but I can find it. I can find it really quick. So how do I get from 4 to 15? Well, I could divide backwards. 15 divided by 4. And that equals, punch it in the calculator here, 3.75. So my scale factor is 3.75. That was the division, 3.75. So that means that this guy is 3.75 times bigger. Okay, so 5 times 3.75 his kite is 18.75 feet high in the air. So my scale factor from 4 to 15 was 3 3/4. So that must mean my scale factor from 5 to x was also 3 3/4. Okay, now let's try this ratio way. I'm going to do ratio way in red. Okay, so 5 over 4, 5 feet over 4 feet has to be the same thing as x over 15 feet. So x amount of feet over 15 feet. So height to shadow, height to shadow, height to shadow. Okay, so what is 5 divided by 4? 5 divided by 4 equals 1.25. Therefore, this side must equal 1.25. So what we're saying basically is that he is 1 1/4 times bigger than his shadow. Therefore, the kite, because the sun casts the same angle, the kite has to be 1 1/4 times bigger than its shadow. So we'll just figure that out. What is 15 times 1.25? Is also 18.75 feet. So same situation. Please do not get freaked out by the fact that we've got this weird drawing of a kid in the kite, and we've got to find out how tall the kite is. It's the same thing as if we just put it up as 2 triangles and find the missing side. Same with a mirror problem. A mirror problem would be this. We've got two triangles that face each other and they're similar. They share the same angles here and here. Okay? They share the same angles, and then you would find the missing side here, and this would be 2, and this could be 5, and this could be 7. You know, whatever. You could find x. Doesn't matter. Okay? And then the inside the triangle thing, I want to talk about that. All right? Let's draw this situation real quick. This will be the last thing we do. This is a great test question for the OAAs. Okay? So we've got this triangle here. And then there's another triangle with inside it. Okay? And we know that this part right here is 10 feet. This part, the remainder of that side, we don't know. Okay? Now we know that this bottom leg here, and on the one on the inside of the triangle, this is 15 feet. And then down at the bottom is 20 feet. Okay? And we got to find this small section right here in red. How do we do that? Okay, well, we basically have two triangles here. Okay? We have this triangle here. If we just pull it out, we can move this thing with it. Okay, that's 10 feet. We know that this is 15 feet. And we know that this little x portion, we don't know what it is, but we can find it because we can just subtract it from this, which we know is 10 feet. Okay? So we have the 10 to 15 and the 10 plus x is 20. I'm going to do ratio. So what is 10 divided by 15? 10 divided by 15 equals 0.3 repeated. Okay, so we're saying that, I'm sorry, 0.6 repeated. What am I doing? The upright leg is 2/3 the size of the base. Okay, so now we know that. Can we find what this total leg here is? Yeah, we can. Okay, so what is 2/3 of 20? Well, let's punch that in our handy-dandy calculator. And it's 13.3 repeated. Okay, so this whole side is 13.3 repeated. But I don't want to know the whole side. I only want to know this much right here, the x. So what would you do? Yeah, we know that this is 10. I don't want the 10. I just want that little leftover spot. So I know that x equals 3.3 repeated. 13.3 repeated minus 10 equals 3.3 repeated. Feet. Don't forget the feet. Won't get full credit. Okay, so this is a nested triangle type problem. I know this video was a little long. There's a lot of stuff jam-packed into it. Break it down, and then once you go through and find your scale factor, you can find how much bigger is it, okay? How much area difference do I have? If you wanted to do scale factor in this problem here, you could go from 15 to 20. How do you get from 15 to 20? Well, divide 20 by 15 and find your scale factor, and you can now find the other side because you have your scale factor. All right? So, again, good luck to you as you explore and learn new math.